probably been at all these places, right? And I thought I'll take you through my journey. So about 93 was when I graduated. No, not even 93, 80, yeah, 91 was when I graduated from bachelor's in mathematics. And post that, I did the master's in statistics from Indian Statistical Institute. That's from when I know Shiva. And even that story was different, right? I always wanted to do master's from ISI. So I really wanted to study the BStat course as well, right? And when I went to write the entrance test, I by mistake sat for so there are two papers. The first paper is objective, and the second paper is subjective. I wrote the first paper for masters without knowing, right? And when I looked at the second paper, I couldn't understand anything, and that's how I lost it. I couldn't get through the bachelor's, but then I worked hard, and then the next time I cleared it. It was a great experience. 2 years, made some great friends. And there, my specialization was applied statistics and data analysis. So immediately after that, there was a boom, the IT boom, right? So I joined the industry. And typically in an IT industry, when you join as a developer, if all of you might know, right? But actually I joined as a trainer. So the only one program that I knew was Pascal those days. And they immediately asked me to teach a bunch of professionals from Indian Market Research Bureau in Delhi. And they said, can you teach Pascal to them? So that was my first tryst with teaching. Did that for about 2 years. It was, again, interesting because DOS and Windows was all coming up at that point in time. And we used to go around teaching, you name it, all these, public sector fellows, your LIC and all of them, we used to teach them Windows and all that. And post that, I entered the actual career of developing applications, went through the whole grind. So you start developing, then you start to, manage teams. And slowly, the client server era started, and then there was Java, and all of that went through all of that. And as programs became bigger and bigger, so there used to be a new role, started coming of testing. So then, and also figuring out how to, understand new technologies that are coming up the horizon. So all of that happened, and I was with the industry for about 20 years when I decided that, this is the right time. I really want to do something else. That's when I took a break, an academic break, and decided to pursue a PhD. But before that, of course, I met up with a lot of people because it meant, something, you get used to a certain kind of a lifestyle. It's a predictable lifestyle, right? You go, you're working. And at that particular point in time, I was actually heading a very huge business. They call it the rest of the world in the corporate industry, where, so all of the nations except US, UK, and Latin America. So almost all of the business applications functions were rolling into me. So I didn't even know whether I was ready to do a PhD. And that's when I remember Shiva was one of the people whom I spoke with, and he said, let's see whether you're ready to do a PhD. So I actually interned with him for 3 months, where he took me through, he said, this is the life of a researcher. Let's see whether you're up to it. So some papers, he said, read through the paper, reproduce the results, go and listen to the talk in Indian Institute of Science. I did that. And, it made me realize that, yes, I'm okay. I can do this. And then came the hard, I had to study. I'd forgotten all my math. So I was looking at what you guys are learning so now it doesn't look Greek and Latin to me because it's just a few years back, but I had forgotten everything. So I had even forgotten how to read dense books, right? So I went back, studied, and that's how I applied to the doctoral program at IIIT Bangalore. And that's where I pursued my PhD for 5 years. It took me 2013 to 2018 to finish it. And the topic was very interesting. It was about semantic web. I was so motivated with this area that I decided to start a company, right? And 2019 was when we founded Semantic Web India. But as luck would have it, I rammed right into COVID. So it was very hard to generate funds to keep the team. And it was a bootstrapped company. If you all know, bootstrap means you're pumping your own funds into the company, right? for about a couple of years, we struggled, but now we are trying to get up on our own feet. We have been recognized by the Startup India Seed Fund Scheme. We've seen some funds flowing from there, and we've kind of stabilized, right? So that's my background. And today I'm going to take you through this very fascinating world of natural language processing, right? Many of you, I'm sure, in your day-to-day life, through some application or the other, are using, one of these NLP-based programs. If you're using Google, you're using an NLP-based program. If you're using your, Translate, when you kind of suddenly want to translate something in one language to the other, Hindi to English, Tamil to English, then you're using NLP. It's there everywhere, right? So let's see, right? And I want to keep it really interactive. Please stop me, right? The whole idea of taking you through my journey was to make you feel comfortable. Shoot your questions at any point in time. I would love to talk to you post the talk, right? All of you, it's simply amazing. So many of you, and I think you're representing every part of India, almost, right? I mean, all the states in the southern part of India was covered this way, even Assam, West Bengal, right up till J&K. Right, so this is what we're going to be talking today. I'll take you through some basics on natural language processing, some of the applications that you see in day-to-day lives. Typically, we're going to go through one application of NLP, which is the question answer system, right? And how did we actually make this work? I'll also be taking you through some approaches to question answer systems. There are multiple, but I've selected 3 for the talk today. So what exactly is natural language processing? Just getting comfortable. Yeah, okay. So very simple. You want to make the machine understand in your own language what you're talking to it, right? So one of the things that you do is machine translation, where you write something in a language, it comes back with, with a translation. So there is some component of NLP over there. You do information retrieval. There are people who type in on Google search or any other search platform. Sometimes you just type in a few words. Sometimes you type a full sentence. Sometimes in the middle of the sentence, it is trying to prompt you, are you meaning this? Do you really want to know about this? There's an NLP component there. Sentiment analysis, where you go to a restaurant, you like something, right? And then you automatically convert that into a sentiment. How does that help? It helps because that particular product organization is wanting to sell you more of the same stuff, right? Information extraction, very important, especially in the biomedical domain, where the doctors don't have time. They just type in a few sentences into the application, and they expect the diseases or the disease symptoms to show up automatically, right? So a stroke has to get mapped to a heart stroke, right? Third most common cause, it really has to rank the results. So all of this has to happen, right? Then question answering, of course, right? You sometimes, a lot of times, if you've booked a ticket on Make My Trip, for example, there's a small thing that comes on the side, may I help you, right? So it tries to understand what you're trying to say and then converse with you as though it's a human. It's not, right? It's a bot. Up till some stage, it's trying to answer your questions. So this exactly is what NLP is. So how do you do it, right? So the most common thing that you would want to do, specifically this happens when your mails get segregated, right? Your mails get segregated into spam or not spam. So some of the mails automatically go into the spam folder. So there is some amount of NLP component working there. How does it do it? So typically a spam document will have something fishy about it. Either the mail ID will be fishy or some content will be a promotional content, right? So what really happens is, so there are these machine learning algorithms, which basically, in which you create some features which are useful to detect those cues from your documents, right? And those documents then get classified into spam versus non-spam. Other examples could be when you have multitude of documents in the web, you have to classify it into something related to history, something related to politics, and so on, right? So this particular way of doing it is an entire document classification. Typically, it is done in a process called supervised learning. Supervised learning is very similar to consider a toddler, right? A baby. So it is taught that this is your mama, this is your papa. And then slowly the child understands that when there is a face, two hands and two hands, it's a human. But whereas, it can differentiate between a person and an animal, right? And slowly it then differentiates between wild animals and domestic animals, right? So how does the child do? Internally, also the human brain is only looking for cues. If these cues are there, I understand that this particular. So that's the same thing that we are trying to do programmatically or algorithmically, right? The other one is, of course, instead of the whole document, right? So that's one way. The other way is when you're trying to write a couple of sentences or a paragraph, you divide it into tokens or words, as you call it, phrases. Sometimes a token could be more than one word. And then you try to classify. Typical examples here again is, if you have picked up a cloud space, or again, I'll take the same example of your ticket booking, right? So if you are asking for a refund, they automatically point you to a different team. Yeah, your Uber, for example, if you're canceling your car, it goes to a different place, right? You're trying to, so depending upon the kind of question you raise to the team. So internally, what is happening, that entire sentence is getting chunked into various words, and then, some processing is happening. How does this happen, but? Right? It all seems so simple. It's not so simple, right? And I'll tell you the pitfalls. So look at some sentence like this, right? So there are a lot of sophisticated algorithms, and these algorithms come by means of Python libraries. Python is a programming language. So, in terms of Python libraries, where if you run your text through those programs, then automatically it says, oh, this word I understand. This word is like, I understand Portuguese, it's a nationality. Right? I understand Brazil, UK, it's a geopolitical entity. I understand that. Similarly, dates, all forms of dates, for example, and organizations, it's able to understand. But can it understand every single organization in the world? It cannot. Ultimately, this thing is working on the basis of what it has seen before, what you term as your prior knowledge, whatever you have seen before. And an algorithm can only be as intelligent as what it has seen. But there are ways to make this particular algorithm very intelligent. How can you do that? Because of the way English language is structured, or because of the way any language is structured for that matter. When you structure a language, you know that there are certain words that come at the root of the sentence. You know that, if I am going to, it has to be a place. I like this, right? But there are caveats, right? There are certain words where you really don't know what it means. There was a fence that separated the house and the garden. I was so tense that I was on the fence. Both the same word. How do you make the computer understand? Right? So these are, some pitfalls of how we can make it understand. Of course, I'll just tell you how we have overcome those situations as well. So that is one way. So there are, you can figure out those tags. The other way is the second example that I told you, right? How do you distinguish the context of that particular word? Is by means of breaking down the sentence into what you call WP is actually a which pronoun, WH pronoun, right? Or VBZ internally means a verb variation. DT is a determiner, JJ is an adjective, right? So when you chunk your entire sentence into these typical brackets, then actually there is some hope of understanding that fence in this, what I was talking about, right? To make things even more simpler, there are also something called dependency parsers as you move through it. So these are all various techniques of NLP that I'm exposing you to, right? Just so that you understand. So here, if you can see it, the flight, right? So if you see morning flight, the N mod, something that particular feature called N mod is connecting morning and flight. So it basically is trying to tell you that, morning is actually modifying the word called flight. So it must be related to each other. So typically we use a lot of these dependency parsers to understand the root of the sentence and all the dependent sub-sentences. So I can take it out, right? And when I look at more such sentences with such phrases coming together, then I know that, okay, fine. So if a word is used in this manner, it could mean this, right? So that's why your algorithm gets more intelligent, right? Okay. At our organization, we actually work a lot with semantic web. Semantic web is a means of adding context to the data in a machine readable form, so that the computer now starts understanding the context of the data in the same way as you guys do. For example, if you say I'm from Mumbai, it is no longer a 5-letter word for the computer. It now understands that Mumbai is a city in the western part of the nation, and it's the financial capital, exactly the same way as you guys understand about Mumbai. How do we do that? That context of that data is actually fed into the computer in the form of a machine readable knowledge, right? So that's what semantic web is all about. So today, when you actually type in, earlier when you used to Google something, it used to just pull up all the related links. Today, when you actually type in, if you say IFB, it says, I know, what do you want? You want an IFB washing machine or an IFB microwave, for example, because it understands that IFB is related to both of them. Okay, so in a semantic annotation, what you do is that machine readable knowledge that I am talking about is actually this. Oops, I'm so sorry. Yeah. So it's actually this knowledge graph that I'm talking about. As you can see, Roman Empire has capital Rome. Roman roads are located here. So this kind of graph is what is created with all of your data.
For that, won't we have to feed like the data for each and every word, and that would be tedious. So how do we make it but not consume a lot of?
Yeah. So typically, what happens is your all of your Wikipedia, everything that you see in Wikipedia. So the summary part of the Wikipedia is already pulled out and converted into a graph. That has already been converted into a graph. So we call it DBpedia. It's a large graph, right? Similarly, WordNet, where every single word, its synonyms, its antonyms, it's already been converted into a graph. So as now what happens is, as more and more knowledge is being unearthed, they go and stick into this particular same graph, because the same node is now getting enriched exactly the same way as that child example I told you. So the child sees a bird and says, aha, okay, birds fly. But then when it sees a Tweety bird, it says, oh, Tweety birds don't fly, or maybe they just fly small sentences, right? So what is happening is, more and more knowledge, as it comes in, it goes and attaches itself to some node in that graph.
Actually, research now, even before this entire thing started, there must be a lot of data already in the internet. So how did people categorize them and then add like the new data?
So the DBpedia movement is just one example. The DBpedia movement started about probably a decade back, right? So they started and then they built it. And today, just check out this thing called Linked Open Data Cloud, LOD cloud. Now, earlier there were some few billion. Now it's like unbelievable amount of tuples over there, right? Not only that, especially in the biomedical domain, the diseases, how do you define a particular gene, or how do you define which disease has which clinical features, right, or manifestations. All of that has been converted into knowledge graphs, right? And so now, if you are able to intelligently link your data to that cloud, you can do a lot of stuff. So you no longer need those kind of domain experts. Earlier, what used to happen, a machine learning algorithm would spew out some data, but then you need a domain expert to understand that and to cluster that. But now, with the domain also being fed through these graphs, computers can do a lot more. Right. So that's what I was trying to explain. You create machine readable knowledge, and then the algorithms, they identify what is called named entity. So these are all terms that, if any one of you here try to pursue a sheer data science field, so they named entity recognition, right? Context disambiguation. These are all standard keywords or terms that are used. Okay, so this is what I was trying to explain. So one of the applications that we ourselves have built, because our organization works in two domain verticals. One is the life sciences and genomics, and the other one is the public data application. So in the life sciences and genomics, we're actually building a platform for variant analysis, which helps in detecting rare genetic disorders. So as the clinician is typing out, the features, like if they say large forehead, narrow mouth, broad chin, patient has asthma symptoms, immediately it knows that, okay, the doctor is talking about a microdeletion syndrome, right? Which earlier was only there in certain brains of certain doctors. Now, you can easily, make this work. It's not so simple as I speak. There's a lot of work that goes beyond, but it is possible to do this, yeah? Sentiment analysis, we've already spoken. Cognitive assistant, again, these applications where the may I help you thing, right? So that's the cognitive assistant. Identifying fake news, so important, right? So fake news have got a pattern. And again, your NLP can help in identifying that. Talent recruitment, extremely required. I can say from my own experience, we get bombarded with about 100 resumes every week. If we want to pick up the right one, we need something which just gives us exactly what we need, right? Okay, let's move on to question answer systems. I wanted to leave about 10 minutes for all of us here for a QA session in the end. So how does a question answer system work? A question answer system, it's like I ask a natural language question to an application, to some platform, and it returns knowledge as far as it is, as much as it knows. Many of your sites have FAQ, right? You type something and then it comes back with the most suitable answer. Most likely there's a Q&A system running behind it. And this definitely uses NLP, and I'll tell you how. In fact, we ourselves have implemented this. Consider that particular text that the person is entering. Smart manufacturing companies. Can you tell me some smart manufacturing companies within 100 kilometers of Coimbatore manufacturing industrial refrigeration equipment, right? So now there is all this data available here. In some way, some structured way, this data is available. Now, the idea is that for this question, I need an answer, right? The user doesn't want to really go into the details, gory details of how the database is, has stored and all of that. I should be able to ask any NLP-based question, I should get the answer. What does one have to do? The first thing I have to do is I have to identify the intent of the question. What is the question seeking? Is it seeking a place? Is it seeking some particular object? In this particular case, it is seeking some organization names within a vicinity of another location, which is manufacturing something, right? So the second thing is I have to do the entity and context extraction. When I say context extraction, first of all, there is a smart manufacturing, this is an entity. Industrial refrigeration component is an entity. But somehow I have to understand that this means I'm looking at companies which are 100 kilometers within Coimbatore. These two things is the most hardest one. And I'll tell you how people typically solve these problems. The rest is kind of simple. Once you extract, you map it to the repository, and then you get the results out. So let's see what are the ways of solving this. The first way, the approach that I'm going to discuss today is it's called BERT, bidirectional encoder representations from transformers. So typically what happens is it's very, very costly, and the questions that you raised. So here, multiple different types of questions have to be trained to that particular algorithm. And for each type of the algorithm, you have to say that these were the entities and this is the likely answer. Then when you send a new question, it will try and understand, okay, so many other questions I have understood, I have been taught how to answer, possibly I can answer this one. But this kind of thing is very, very heavy on training data set. It takes a huge effort to, first of all, create those training data set. That itself is an industry. So where people want training data sets to be annotated, which we call ground truth. As you go ahead and write your papers, right? Typically, when you come up with a model, you're supposed to say what is your gold standard? right? What is your results? How do your results compare to gold standard? So that creation of that gold standard or ground truth is a massive effort here. Okay. So it works when you have a broad corpus of knowledge with varied training data sets. So there is enough number of research articles where people are trying to answer questions on Wikipedia, because it's a huge corpus, and you can build many algorithms here. But look at certain other things. So we were faced with a problem like this. So very recently, in fact, we are still doing it. We are collating all of this COVID-19 data on how many people recovered, deceased, and deaths. And we just want to ask some simple questions, simple questions like this: how many people died of COVID in Tamil Nadu during May 2022? Or which district in Punjab recorded the highest, COVID deceased case, right? Simple questions like that. I cannot afford to have a huge training data set here, right? So I cannot afford to have, I have a limited question template, I have limited training data sets. How do I handle this? So what we did was, we actually identified these various entities using all those techniques that I spoke about, the NLP combination of all of that, and the question classification. Now here it was simple for us because the question classification can only be three. Either you want to know the time, when, where, which, right? So depending upon the context of your problem, you need not go for a big, what do you call, like हिंदी में बोले तो हथौड़े से जब काम हो सकता है, so you don't need something so huge to do it, right? So that's how we kind of used a different approach to create a chat layer on top of the COVID data. This is something that we want to do when you have, as I said, there are a lot of people who are creating, knowledge graphs based on many different kind of data sets, right? Especially in the genomic space, there are umpteen number of data sets specifically for neural diseases, cancer diseases, and so on, right? If somebody wants to ask a question on that particular knowledge graph, it's still kind of an open problem, because when you have such massive data sets, I ask a question and I want the best answer from that knowledge graph, right? So this is something that we want to do. We are actually working on this particular problem now. A knowledge-based, graph-based question answering system, what does it do? It identifies the entities which actually map to some entities here. Not only that, it has to identify from natural language the closest relationship. These edges here are relationship between two data entities, right? So I have to predict the closest relationship for that particular edge. And that, if I get it from the question, all I have to do is get that particular this tuple out, and that will be the answer for the question. So that's what we are working on. Yeah.
So for example, in Google, when we put a question amongst articles, it highlights an answer, sometimes right in the beginning, so that you don't have to click on a link to get an answer.
Yeah.
So is that sort of what's happening?
Yes, behind the scenes, yes. Behind the scenes, there is a Google Google knowledge graph that's in play. They have like tons and tons of computing storage, right? So all of the data, every single query that processes through the platform, they convert into the nodes and edges and store it. So when you type sometimes when you type a question, if there's a direct match, they just give you the answer. There is no need to go to any specific link to get the answer. Yeah.
My experience, about 10% of time, it's absolutely wrong.
Yes.
There's no feedback but time.
There is, yeah, and this is a very important point. So this is exactly the point that she said about feedback, right? That's the reinforcement. So suppose I have asked a question in the COVID case, right? The thing that we are building, if I could not answer the question and the user says, no, I didn't talk about this, I was asking something else. So what is it something else? If you know, then I can actually feed the data back into the loop. And we want to use a combination of that BERT model, because now we have the data. You see, now we have the data and the answer. So I can actually use a combination of this knowledge graph and BERT. So that's what we are actually aiming to do. If we, yeah. So it
would also help, like basically we are also training.
Yes, that's right.
What is the latest of this part?
Very good question. Yeah. Very good question. So that's one of the reasons why there is a new area of research which is coming up called explainable AI, right? So without us knowing it, because of the way human beings are, there is a bias towards, certain answers or whatever, right? So now to remove that bias, they are saying if you're using a neural network tends to be biased because it is based on data and the data is biased, right? So you need to figure out, so that's where semantic web can largely help, because there is nothing black box about that. It knows exactly which. So ultimately what's happening here is, in this graph, it is going to traverse a certain set of, it is going to traverse a certain path here to give you the answer. And that path will be totally open. This is how the answer was provided to you, right? And that's why people are moving away from a black box neural model to a semantic web enriched model, so that we know exactly why that answer came up, right? Okay, so I thought if I had time, I'll quickly show you. So this is what we built. It's still, there's a little bit of, it's fragile at ends. So we are still trying to kind of get it to work properly. We tried BERT, it failed miserably. Then we tried a combination, that the second option that I showed you, that's working very well. The third option, we are yet to, kind of try it. But the second option of trying to just understand the entities and then a pure rule-based system worked pretty well on this. Let's see whether. So if I say, something like this, right? So, oh, it's not visible. So I have to share. Let me see, I have to go back to Zoom. I need to get back there and somehow share the desktop or something. Yes, yes. Oh, it's still not showing, I think. Oh, okay. Yeah. It's showing now, right? Yeah, fine. So let's see. Something like this, right? So we tried to cover, we first said we will do 6 different questions. So we actually thought what all can a person ask? Either they ask pointed questions, or they say, what is the most number of cases? What is the least number of cases? How are the Northeast states doing with respect to all kind of, some 6 combinations we took, and it seems to be working, not fully, but to a large extent. But we still have to, kind of get this, the fragile part kind of handled. But in this particular case, we exactly tried the second case. So let me just show you. I think, let's see whether the other one. Um, Okay, something like this, right? So here I did not put any date, so it automatically assumes a particular date and says, something like this, right? So this is what we attempted with the COVID data. Yeah.
It's actually not guessing or estimating these
No,
numbers.
no.
There's a database
Yeah.
of raw numbers
Yeah.
available.
Yeah.
So, is there also like the source of those numbers available as well?
Yes, very much in all forms. Whether you want to see it in the raw form that came from the state portal, or in the processed form in which we store it, or the knowledge graph form. So all three forms are available for you to go ahead. So in fact, what we want to do also is kind of add that if you click on the graph, it can actually take you to the graph and you explore the graph. That also we want to add into the same thing. So I think, yeah. When there is no data.
When there is no data, or when data has not been collected, like we can't build a system then. But what do we do in that case?
Then what exactly is your,
for example,
what do you want to solve? The problem that you want to solve, then maybe I can think of.
Like a small example would be like we take data from Wikipedia. So mostly on Wikipedia, people don't write about regional cinema, but they write a lot about films in Western media. So we have a lot of data about Western films, but not about regional films. So in case we make a question like which is one of the best sci-fi movies, so we'll probably get a Western like film. So there is no data, and people will not be writing about it anytime soon. So how do we do it?
How do we do that? So what we could do is that this data for Western films, the way it is being stored in the form of a structure. What is that structure? The structure is very simple. There is a subject. I'm talking about the way DBpedia stores it, right? So if you wanted to solve it without semantic web, with a pure NLP based thing, then there is no other option but you have to generate this data, right? Your local database you have to generate, and there are ways and means by which you can train the algorithm to understand this. Okay, yeah, and I'll tell you how. Okay. So if you look at the movies database, right, all of the sentences will have some structure like this. This movie is a sci-fi movie and the plot is this, was directed by this, these were the main actors, right? Typically the sentence is the same. You can actually create your own custom data set, as you call it, for all of the regional movies, which are actually kind of overlapping with the same structure of that particular sentence. And you say that now my training data set is augmented with my local data set. All of these algorithms that you saw, they give an option for you to augment your training data set with custom data. If you look at the kind of districts that India has, 840 or something, Wikipedia does not know about all that. MON is a district somewhere in Northeast, right? So if you ask how many COVID cases in MON, it won't know. But this one knows, because we actually created the entire knowledge graph is filled up with our own data, right? So even the same thing is possible with an already trained data set by adding these new places. It's possible.
So is this also the reason why, like on translation systems, some regional languages don't have very good translations?
Correct. It's
because of the lack of data.
Yes, it is because of the lack of it. Yeah. And because of that point that Dutika mentioned, that there is no feedback mechanism. If you kind of say that if there must be a way of saying that I'm teaching you this, add it into your knowledge base, and then now it should become into your bigger data set. That has not happened.
Is there feedback in the sense, like if there are 10 results and people consistently do not pick, like let's say the 10th result, then is there like a sort of feedback that is wrong or that's not as relevant? Does that happen?
Very much, very much. In fact, there's a ranking algorithm for this, right? So the way it works is when it returns some 10 results, right? So if your first answer was correct, so it gets a score that my very first answer was right. If the second answer is right and the first answer is wrong, then again there is a score. So what happens is there is this scoring algorithm. I'm forgetting the exact name for that. But if the 10th result in this particular case will automatically be discarded, because the scoring actually says that, okay, this is exactly the way your Google results, search results also work. So the moment you click on something, it physically internally scores that second result as the right one, and all of the others get a lower score. So when the same question gets asked by a different user, the second result, if it has been clicked by multiple users, will come up, right? And that is how your search engine optimization also works. If you want to make your site very popular, so there is a way by which you can do that, right? You can beat the system. Exactly using that. Yeah. No, it's not PageRank. It's not PageRank. PageRank actually tells you which particular page is the best given this particular context. This is a specific scoring algorithm. So it is used largely when you are publishing data science results, right? So if you, from the first 10, some ranking algorithm, I'll get back to you immediately, right? Yeah. Yes, very much. In fact, the Google Analytics, right? So if it does not just give you the number of times you click, it doesn't do that. It can actually, it understands who's clicked it, which IP has clicked it, and all that. It does some internal mechanism, some checking mechanism, and only then it puts the pertinent, it's called MAP. The algorithm is called MAP, MAP. What's the full form, Shiva? You can just Google it. It's called MAP. I know for sure it's MAP. I'm not remembering the full form of MAP. What is it? Maximum? Yeah, it's the algorithm itself is MAP, MAP, to actually get that rank. Yeah.
Can we use to obtain a point estimate of an unobserved quantity?
Okay, no, it is not as complicated as that. I'll get you in fact, I'll send the link to that MAP algorithm to you, because incidentally, I used that in one of my papers too.
Ironic is MAP is not showing up at the first.
Yeah. So it's ironic that it is not showing. Very well said. Mean average precision. Yeah. Good. That's the one. Mean average precision. That's the one. Yeah. Anyways, coming back to this, so that's the end of my talk. It was just to kindle, a little bit of thought in your brains as to, what all you can do. It's fascinating. It's so interesting. Good luck to all of you, and thanks a ton for being so interactive. I really loved the audience today. Yeah, we can still. It's just 2 minutes to 5 though.
So you can either ask questions now, or usually what we do is the speaker sits outside those tables. Maybe you're working in the afternoon. You just make a circular formation, or say round circle.